welcome to the Penguin Post newspaper by Kids. Today we're interviewing Joni Meyer. He predicts fire with math. That's so cool. Let's ask him some questions.
Why do you study fire predictions?
Well, I work in something called mathematical ecology. And mathematical ecology is using everything I can from mathematics, to study and sometimes understand and sometimes even predict phenomena in the environment. Mathematical ecology includes population behavior, population dynamics, how populations grow and go down, and how species come extinct or start catching up again. Then we also study epidemiology, which means sicknesses. So I have a group which I lead, which is studying the COVID-19. We also study global change. And the fourth thing we study in mathematical ecology is environmental impact, is what happens to nature, mainly because of what humans do. And so when I had this researcher who comes from the Amazon region, he said he wanted to study serious problems. It's the third time I've done research with somebody from the Amazon region. One time was studying water and species in the water. And the other time was studying when the forest was cut down, it just raised, and how the forest crept back and recuperated all this area. And the satellite images do not show an empty space, but show a perfectly similar, homogeneous green color. Listen, you have to interrupt me if I say something you don't like, or that you don't understand, or if I use some sort of word not too well, okay? I'm Brazilian, so my English is probably, so that's why I studied forest fires, because that's a very serious environmental impact problem in the Amazon.
How do you use math to predict wildfires?
Well, we use math in order to teach a computer to identify places where there is fire risk and where there is fire danger. In some places, it is very dangerous because fires are common and because of the wind situation and all that. Fire risks is when you have an environmental situation where a fire danger might appear. And so we work with fire risk and fire danger. They are not exactly the same thing. Fire danger is a more present risk, and fire danger is a situation in which the risk can appear.
What is the difference between wildfire risk and wildfire danger?
Well, most of the fires in the Amazon region are not wildfires. They are started by people who want to burn the forest down and then use it for grazing, or for, I think it's only for grazing because the topsoil is very rich, but it isn't very deep. And so probably we do have wildfires, but most of the fires in the Amazon region are not wild. They are brought about by human beings with no scruples, with no interest in nature, with no vision of the future, because they're destroying what they're going to need and their children and grandchildren are going to need. But they do it anyway to make immediate money. So what I would say about risk and danger is that in some places, there is a danger of fire. We already have a very dry situation. We have, when the leaves fall And then we have lots of not undergrowth, not these plants that live under, but the dry leaves. And so we have a risk of fire. If nobody lights a match, if lightning doesn't strike, we won't have a fire, but we do have a risk. Now, a fire danger is different because everything is set, everything is all ready for a fire to start, even if it is a wildfire. But in the Amazon, our greatest concern is not for wildfires. Our greatest concern is for fires brought about by people who want to destroy the forest.
Have you ever seen a big fire? If you did, what was it like?
Scary, really scary. And it's scary also because if a house is on fire and you want to help somebody, you know where the fire is. But if you're in the woods, or if you're in like in California, how come so many firemen get killed during the fires in California? They have experience. They know how to operate. But the fire might certainly turn around behind you and catch you, or just circulate you, so there's no way for you to escape. And so that's what I can tell you. It's very noisy. The wood snaps and the plants pop, and if there are bamboos close, they explode, and it's very noisy. It is very, very, very hot. The smoke doesn't let you breathe. It's very bad for your health. And the light, if you look at it, then you have a hard time looking at other things, because it's as if somebody flashed a light into your eyes, and then you turn around and you can't see for some time. You just turn around so you can escape the light. And that's why it's scary. Nothing about it is calm. Nothing. It's just plain scary.
In simple words, what type of math do you do?
Well, I really wish I could tell you, because we work with problems that come from life, from real life, not problems like you have in your mathematical classes. You have 17 minus 5, how much does that give? Or 3 times 235, how much does that give? The problems we work with are never like that. The problems we work with are problems like, where is the fire going to be worse? What is going to happen with a COVID disease in Brazilian regions? What is going to happen if you have an oil slick near beaches or near fishing areas? And what's going to happen when this oil appears and it spoils fishing, it spoils fishing grounds, it spoils tourism, it spoils quality of life? And so how can we predict where this oil slick is going to go with the wind and the tides and the currents? And so we use whatever mathematics is necessary. And so I am 73 years old, and I am still studying mathematics. I still have to study mathematics. So I can't tell you what kind of math. But I can tell you one thing. We can do nothing without adding, subtracting, multiplying, and dividing. That's it. And thinking, of course.
What are some things that make a forest more likely to catch on fire?
The dry weather. This doesn't happen too much in the Amazon. But if you look at the a little bit in the map of Brazil, you have the biggest swampland in the world. It's called Pantanal. Pantanal means swampland. And at this time of the year, because in Brazil, we're still in winter, because we're in the southern hemisphere. So the world is a globe. And then when you in the US are close to the sun, we are far from the sun. And then the earth goes round and round. And then when we're close to the sun, you're far from the sun. So when it's your summer, it's our winter. And in our winter, it doesn't rain. It is very dry. Our rain is during the summer. Maybe you might have heard of something called monsoon. Monsoons are very strong rains in India. And this is the kind of rain we have in the summer. Well, in the swamplands, in July, August, September, we still have very dry weather. And so everything is parched and the leaves are dry. And a fire can catch very easily, very easily. In the Amazon, you have lots of wood. And if a big tree falls, it just sits there and rots. And a big tree like that, but it's an enormous tree, is all ready to start burning and to burn and burn and burn and burn. Sometimes it burns on the inside and then it moves on to the outside. And so this is one of the natural risks of fire. But in the Amazon, there is another thing, which is people who want to destroy the land for their own profit. Now, these people set fire to the forest. They are the worst fire hazard there is in Brazil.
How do you inspire an 8-year-old girl to learn about math?
Well, what I like to do is I ask a group of 8-year-olds, what is the main problem where you all live? And if you mention a problem, it has never happened in all these years in which I've been working with this, it has never, ever happened that we cannot use mathematics to understand a problem better. For example, we needed to measure a short part of a stream because the trash in the stream was the biggest problem. And so we had to set out and measure it. But how could we measure? It was maybe 500 yards or something. There was no way we could measure. So what did we do? We got several kids to walk and count their steps, and then we used their steps to measure the size. Another thing, we can go to certain areas, and every time you find something which does not belong to nature, for example, a tin can, or one of those little plastic cups you use for yogurt, or small Coke bottles, and I don't know, Lysol, what do you call them? Those kind of bottles you put Lysol inside. Every time you count one of those, you can make a little mark on a big sheet of paper. And then you go to another place and you do the same thing. One time with red, one time with green. And then you compare. And then you see which place is more affected in the sense of preserving the environment. And you can count how many little signs you made, how many green signs, how many red signs, but you can also look at this big mess of things and see which is bigger. And so we're using mathematics. Of course, there's no multiplication at this point. There can be, of course, there can be. How much water does each person spend every day in your town? How much water? So how can we do this? We get all the water which is used in one day, and we divide it up for each person. So we use mathematics to understand if we're wasting too much water or if we're economizing water. When you flush a toilet, how much water goes into it? Here in Brazil, all new flushes they have two buttons. One, if you peed and it's less water, and one is for the other situation. And so you have more water because you have more things to take away. So to do this, you need mathematics. But I don't know if this is inspiring, but everything that happens in your classroom, how far do you have to be from each other? Can you put 3 more students, 7 more students in your class? Are you going to be crowded? You have to measure and you have to multiply and add and subtract and divide. So I would try to inspire people not to study mathematics, but to study the world. And when you study the world, you need science, you need English, you need Spanish, you need mathematics, you need history, you need geography. So I would love to inspire 8-year-olds to study the world around us, our classroom, our home, our backyard, the region where we live, our town. When we do that, we have to learn mathematics.
How can we enjoy math more?
I think doing what I said, instead of me forcing you to learn that 8 times 7 is 56, and you have to learn it off by heart, let the calculator do it. What I would like to do is make you look around you, look at your family, look at your television set, look at your kitchen, look at your backyard, look at your 5 houses on your street, and then to study what happens there as the world we live in, we need mathematics. And so mathematics, it can be fun. I like it. But I don't think it has to be fun to everybody. But it's necessary. We need mathematics to understand what's the matter. For example, you have 12 kids and you have 16 hot dogs. How do you share them around? Yeah. You take 12 away from the 16, give 1 to each, and you have 4 left. And you divide those 4. Each of the hot dogs you divide in 3. And so everybody gets 1 hot dog and 1/3 of a hot dog. Yeah, I use mathematics, but not because I want to use mathematics. It's because I wanted to share the hot dogs.
That was so cool. We learned a lot from you, and thank you for your time. Bye.
Oh, goodbye. I'm sorry. I'm very boring. I'm a math teacher. Goodbye. Thank you much for the opportunity. I think it was a privilege to speak with Penguin. And I'm sorry I was late.